If you recall, when we talked about the normal distribution, we talked about something called the normal curve rule, or sometimes referred to as the empirical rule. So we're going to first remind ourselves what that rule is, and then we're going to talk about a new rule called Chebychev's rule. So the normal curve rule, or the empirical rule, told us certain characteristics that would happen for every normal distribution. The two different things that we needed to know were the mean and standard deviation. And what that told us then was that 68% of observations were within one standard deviation of the mean. Then, if I go out 2 standard deviations, I got 95% of those observations are within now 2 standard deviations of the mean. And then finally, if we went out 3 standard deviations, we got 99.7% of the observations. So as long as we knew the mean and standard deviation, and of course knew it was a normal distribution, these 3 things would always hold. However, we've now discussed in this module that not all data is going to be symmetric and unimodal like our normal distribution. So what would happen then when that's no longer the case? Well, if it's not symmetric and unimodal, my normal curve rule or empirical rule will not apply. So that's where Chebychev's rule is going to come in. What Chebychev's rule tells us that no matter what the distribution is, what that means no matter what the picture looks like, at least this 1 minus 1 over k squared of the values lie within k standard deviations of the mean. Now, I give you that formula, but I don't expect you to actually calculate it. So we're going to do the same thing that we did up here. We're going to go out 1 standard deviation, 2 standard deviations, and 3 standard deviations to tell us what that would actually mean for Chebychev's rule. Well, if you plug in a k of 1, which you'll find is not very exciting, you'll find that at least 0% of observations fall within 1 standard deviation of the mean. Now, something that's important about Chebychev's rule that you should note as well is that it has this at least part. So it could be 0% or anything higher. So this is the minimum number, but it could be more. That's different than what we had up here. The normal curve rule or empirical rule is an exact number, versus Chebychev's rule has this at least part to it. So that's why this one's not very exciting. Well, at least no data. So as long as anything is true, this one's going to hold. So it's not very exciting for us. When we plug in a k of 2, or we go out 2 standard deviations from the mean, we'll find that at least 75% of the observations will fall within 2 standard deviations. And then finally, though this one's not quite exact, I'm making it an easier number for you all to remember. That's about at least 90% of observations will fall within 3 standard deviations of the mean. So again, Chebychev's rule will always apply. So technically, the normal curve rule meets this as well, because 68% is at least 0%, 95% is at least 75%, and 99.7% is at least 90%. The normal curve rule is just much more specific, but only applies in certain situations. So how do I know when to use that normal empirical rule versus Chebychev's rule? Well, first of all, again, Chebychev's rule will always hold, regardless. So it doesn't matter if you could have used the normal rule, it always applies. Basically, it always works. However, the normal curve rule, that is the empirical rule, that 68, 95, 99.7 rule, we can use only if we are symmetric and unimodal. And although Chebychev still applies to it, this then is better when it does apply. Because now I'm not just saying, well, at least 75%, but I can say, okay, it's 95%. So it's much more exact. So we like to use the normal curve rule when we can, but if it does not apply, we can always use Chebychev's rule.